Some 4/5 of the Earth's surface is covered by seawater, and dissolved in that water are many minerals. One of these is a group based on the element calcium, and although carbonates make up only about 0.2% of all ocean salts, this is sufficient for many creatures to build their outer protective shells. When they die, their shells settle on the ocean floor. The shells accumulate, and under their own weight, the weight of overlying sedimentary material, plus the planet's tectonic activity, they are compacted in large deposits that can be hundreds of meters deep. In some deposits, there are just a few individual shells, while in others, the material becomes a deep homogeneous mass of almost 100% limestone, easily accessible and suitable for quarrying. Limestone, or calcium carbonate, makes up between 3.5 and 4% of the Earth's crust and was used extensively by ancient civilizations. 4,000 to 6,000 years ago, the pyramids of Egypt were capped with limestone. The Great Wall of China is held together by hydrated lime mortar. And the Romans used limestone to construct engineered highways, some of which are still in use today. In the modern world, limestone, burnt lime, and hydrated lime have endless applications. Fine ground limestone is used extensively in farming to correct pH imbalances. Many manufacturing processes are also heavily dependent on both limestone and lime. It is used in manufacturing steel and as a purifying agent in steel refining. Cement is manufactured by the burning of limestone in kilns. Once it reaches melting point at around 1400 to 1600 degrees Celsius, various additives are introduced. The product is allowed to cool, becoming cement clinker, which is then crushed to produce the fine powder we call cement. Precipitated calcium carbonates manufactured from lime are used in paper, plastics, sealants, food, and pharmaceuticals. Calcium oxide, normally called lime or burnt lime, is made by heating limestone to around 950 to 1200 centigrade to drive off the carbon dioxide. Burnt lime is normally only used for making hydrated lime. By adding exact quantities of water under controlled conditions, the burnt lime is converted to hydrated lime or calcium hydroxide. This reaction is exothermic, meaning it gives off heat, and if uncontrolled, temperatures can reach up to 350 degrees Celsius. Hydrated lime is a very versatile product, and it's used extensively in manufacturing steel, gold recovery, paper making, sugar refining, tanning, and fellmongery. It is also used extensively in environmental applications, such as wastewater treatment and water purification, neutralizing industrial acid streams, pollution correction in air and water, plus it can be used to absorb CO2 and sulfur from waste gases. It is still used for soil stabilization and remains an important ingredient in building highways. This is the story of one company's contribution to the New Zealand economy.
Hi, I'm Robert Webster, Managing Director of Websters Hydrated Lime Company of Havelock North and Hawke's Bay. Back in 1946, my father Bruce, his brother, joined forces with an uncle and purchased the bankrupt lime company on the outskirts of Havelock North. They didn't know anything about lime, but Dad was an engineer and his brother an accountant. When they purchased the Waimarama Road site in 46, they took over the debt of the company. They paid £4,000 for that site. In those days it would have been a huge amount of money. The quarry was put there originally because of that was a very good deposit of sinter, which is a very high quality limestone which is formed with the leaching of limestone through the soils, and that most of that sinter had gone. There would have been a third of what they started with was good sinter, and the rest of what they had to work with was a low grade limestone. Well, their uncle was the managing director of Coy Wright and Salmon, which is an engineering company, and he felt that the lime industry was an industry that would move forward, and if they were prepared to have a go, he would help back them. And they decided that that's what they'd do. When they took over, they had no markets whatsoever. They had a short time to learn what to do to get it ready for the killing season at the freezing works, because that was a big market. From then they just went out and worked the market, canvassed the market, and got all of the customers back that the company prior to that had lost, plus some extras, which included the Chelsea Sugar Works in Auckland, which were a big user of lime. They mined using a little bit of explosives, and the rock was broken up with pneumatic hammers. Then it was placed into the kilns and burnt. The kilns were loaded with trolleys which were on rails, and they filled the trolleys up and pushed them out to the kilns and tipped them in. So Dad came up with a model vehicle which was made out of a number of bits and pieces to do this job automatically, and sped the whole program up. The coke was produced from the gas plant in Napier, and they carted that across on our own trucks to our site, and the coal came from Huntley on rail and was hand shovelled out into a truck. To start with, the burnt lime was shovelled into the hydrator where water was added, which caused the hydration reaction and breaks it down into a fine powder, which is hydrated lime. Then that product is put through air separators to take the coarse particles out of it, and the left over is your finished hydrated lime.